In this video, we will be describing a possible situation for a graph. Sometimes you will be asked to describe a possible situation for a graph, but you may need to do some initial preparation. Here's Ria's first bike ride. Read the graph labels to help you interpret the graph. On the horizontal axis, you have time in seconds. This is the independent variable. On the vertical axis, you have distance in meters, which is the dependent variable. This is a distance time graph. Next, label each segment of the graph. It is suggested to use O for the origin. Then you can use other letters for the other vertices. Here's vertex A, B, C, and D. Set up a table as follows with 3 columns, one for segment, graph description, and a possible situation. For example, segment AB, the graph is horizontal, so as time increases, the distance remains constant. There's your description of the segment. Here's a possible situation. Notice that the interval is from 20 seconds to 40 seconds, so the total interval is 20 seconds. You could say that Ria stops her bike and rests for 20 seconds. So here's example 1. Describe the situation or journey for each segment of Ria's ride. Here's our table again. We've already described segment AB where the graph was horizontal, so as time increased, the distance remains the same. And we already said that a possible situation was Ria stops her bike and rests for 20 seconds. So AB is taken care of. Let's go back to segment OA. The graph goes up to the right, so as time increases, the distance from her starting point increases. In 20 seconds, Ria rides 20 meters, because the furthest up that A goes is to 20 meters. Next, we look at segment BC. The description is the graph goes up to the right, so as time increases, the distance from her previous position increases. In 30 seconds, Ria rides 60 meters and is now 80 meters from her origin. Recall she was previously at 20 meters, rises 60 and is now at 80 meters. Finally, segment CD. The graph goes down to the right, so as time increases, the distance from her previous position decreases. In 40 seconds, Ria rides 80 meters and returns to her original location. It's 80 meters because at point C she's 80 meters and at D she's 0 meters from her original location. Here's example 2. Describe the situation for each segment of Iman's warm-up. Here's our table. Time is on the horizontal axis. Speed is on the vertical axis. So this is a speed-time graph. Let's look at segment OA. The graph goes up to the right, so as time increases, the speed from rest increases. Iman takes 3 seconds to reach a speed of 6 meters per second. In other words, she accelerates. Segment AB. The graph is horizontal, so as time increases, the speed remains constant. Iman ran at a constant speed of 6 meters per second for 7 seconds. Segment BC. The graph goes down to the right, so as time increases, the speed decreases to 0. In 4 seconds, Iman slows down from 6 meters per second to a stop. In other words, she decelerates. Here's some practice. You may wish to hit pause here and try this on your own. Yuri is uploading a very large data file. Describe the situation for each segment of Yuri's upload and related data transfer rates. The graph has time on the horizontal axis and transfer rate in megabits per second on the vertical axis. Here's segment OA. The graph goes up to the right, so as time increases, the transfer rate increases. In 20 seconds, the transfer rate increases from a starting rate of 200 megabits per second to 450 megabits per second. Segment AB. The graph is horizontal, so as time increases, the transfer rate remains constant. For the next 20 seconds, the transfer rate is constant at 450 megabits per second. Segment BC. The graph goes down to the right, so as time increases, the transfer rate decreases. We could say that over the next 40 seconds, the transfer rate decreases from 450 megabits per second to 300 megabits per second. Finally, segment CD. The graph is horizontal, so as time increases, the transfer rate remains constant. We could say that for the final 40 seconds, the transfer rate is constant at 300 megabits per second. And we're done. Please proceed to the next video in this lesson, and thank you for viewing.